Hello everyone, welcome to my channel C.S.E-Pathshala. We were studying about Python for machine learning and data science, and in this tutorial we will study about Numpy set operations. So what is a set? As we know that it's a mathematical concept and it is defined as a collection of unique elements. So set are used for various operations in mathematics that involves frequent intersection, union and difference operations. Now, if you want to create sets in NumPy, we can use NumPy's unique method to find unique elements from any array. Okay, that means we will be creating a NumPy array, and with the help of that NumPy array, we will create a set using unique method. But we need to remember that the set arrays should only be 1D arrays. Okay, so let's consider a code and then we will understand how to create a set. Okay, so we need to convert an array with repeated elements to a set. Alright, so let's implement this code on Jupyter Notebook. Alright, so import numpy as np arr equal to np.array. So these are certainly array elements here. Okay, now what we are doing in the next step, we are creating a set by x equal to np.unique arr. Okay, so we will collect the elements which are not repeating, that means we will collect unique elements from there, make it as a set, and then we are printing it with printx. Okay, so let's save this code and run this code. Alright, so here it is. It's a 1D array set. Now, if we want to find a union of the two sets, okay, so to find a union with the help of NumPy, we will use unique value of two arrays with a method that is union 1D. Okay, so let's consider example. We will be finding the union of the two sets. Okay, so here it is. Alright, so import numpy as np arr1. Okay, that means we are creating two arrays, arr1, that is np.array, it is having elements 1, 2, 3 and 4. arr2, it is having elements 3, 4, 5 and 6. Okay, and we need to perform union operation over these two arrays. As we know that in if we perform union of the two sets, obviously all the elements which are present in both the sets will come under a single set, but it will be unique in nature. That means there shall be no repetition of the elements. Okay, and here we are printing it, and obviously we are creating a 1D array of set. Okay, so let's save this code and run this code. So here it is. These are respectively the elements of both the arrays. It's a 1D form of set. Okay, now if you want to find the intersection, and as we know that in case of intersection operation, we will consider or we will select only the common elements from both the arrays. Okay, so in order to find the values that are present in both the arrays, we'll use intersect 1D method. Okay, as similar to the union. Okay, there also we are creating 1D form. Here also we will create a 1D form. Okay, so let's consider example. We need to find the intersection of the following two set of arrays. So here it is, and let's implement it here on Jupyter Notebook. Alright, so import numpy as np arr1 equal to np.array. Again we are taking the same set of array, that is 1, 2, 3, 4, that is for arr1, and 3, 4, 5, 6, that is for arr2. Then we are performing the intersection. Okay, so new arr equal to np.intersect 1D. Okay, arr1, arr2. Okay, so we are giving two arguments, arr1, arr2, plus we are giving one more argument, that is assume underscore unique equal to true. Okay, and then we are printing the value of new arr. So let's save this code and run this code. So here it is. So the common elements between both the arrays is 3 and 4, and we have converted it in the form of a set, that is in a 1D form. Okay, now why we are using this assume underscore unique as true? Because in intersect 1D method we need to take an optional argument. Okay, and this argument is set to true because it is used for speeding up the computation, okay, and it should also be set to true when dealing with the set. Okay, so usually we just make this argument true for the case of set, okay, and just speeding up the computation thing. All right, now the next thing is, if you want to find difference, now in order to find only the values in the first set that is not present in the second set, we'll use set difference 1D method. Okay, so here also there will be two set, okay, or we just say we will consider an two arrays here also, as we did in the previously, okay, and then we are finding the values which are present in the first one but not present in the second one. So let's consider one code and then we will understand that how to find the difference of set 1 from the set 2. Okay, so here it is. Alright, so import numpy as np. Here your set 1, that is an numpy array, is having values respectively 1, 2, 3, 4. And the set 2, again it's a numpy array with respectively the values as 3, 4, 5 and 6. Then we are performing new ARR equal to np.set diff 1d, that is the set difference, and 1D obviously because we want to get the result in a one dimension. We are giving arguments here as set 1, set 2, and again as we said in the previous example also, we need to make assume underscore unique as true. This is done for the set, okay, so we are taking the same parameter here and then we are printing the value of new ARR. Okay, so let's save this code and run this code. Here it is 1, 2. So these are the elements which are not present in the set 2 of set 1. Okay, so 1, 2 of set 1 not present in set 2. So here is the output. Now again the set difference 1D method is also taking an optional argument, that is assume underscore unique, and the concept is same behind it. We just need to speed up the computation, and obviously when we are dealing with the sets we need to make it as true. Now again, if you want to find a symmetric difference, so in order to find the values that are not present in both the sets, okay, so for that we are using set XOR 1D method. Okay, so let's consider one example. That means we need to find the symmetric difference of the set 1 and set 2. So let's implement this code here. Okay. Import numpy as np. Set 1, again we are taking an array, that is we are having the same elements 1, 2, 3 and 4. Set 2, again we are taking array with the same elements as 3, 4, 5 and 6. Okay, and then we are performing the operation, that is set XOR. Okay, that means we are performing or we are finding symmetric difference. Okay, so in order to find symmetric difference we are using a method set XOR 1D. Then we are giving the arguments as set 1, set 2, and with the same argument again, that is assume underscore unique equal to true. So we know all these terms, okay, and then we are printing the value of new ARR. So let's save this code and run this code. So here it is 1, 2, 5 and 6. So it's quite clear that 3 and 4 are the common elements which are present in the set 1 and set 2, but 1, 2, 5, 6 are not the common elements. Okay, so as per our concept, that is your symmetric difference, we are printing the value 1, 2, 5 and 6. Alright, again here is also a same note, that means we are taking optional argument, that is assume underscore unique, just again to speed up the computation, and usually we are making it as true as we are dealing with the sets. Alright, so this is about the basic of how to perform set operations in Numpy. We'll come up with more exciting lectures. Thanks for watching. Kindly do subscribe to my channel.